And we will discuss that one later. Remember what we were discussing in the last class, everyone? What we were discussing in the last class?
Proc tablet.
What is the use of proc tablet?
It is a
Create tables
and a
three
fixed price.
Proc tablet. Data is equal to I'm writing the class data set. I want to have analysis, so I'm writing batch statement. I want to have analysis for height, weight, and BMI. And then I want to have analysis categorically, sex, age group, age. Then I told you mandatory should have a table statement. In the table statement, I'm writing sex into age group, comma. I want to have analysis for height, weight, and for BMI. Now, the height, weight, BMI. I want to have this analysis. I want to have minimum, mean, and maximum. Okay. I want to have minimum value, average value, and maximum value. And I'm writing that one, keeping a semicolon, writing the statement. And this is how we are going to get the analysis. This is what we have seen in the last class. And I told you, if you want to label the minimum, min, mean, max, where we can label that one? I told you we can label that one in the table statement, or otherwise, what is the statement we can write? Key label.
label.
So for minimum, I want to have a low value. For max one, I want to have a high value. For mean, I want to have an average. Getting that one. You can use it only in proc tablet. Only in proc tablet. And then if you want to label the variables, where we can label that one? We can label in table statement. I want to have a gender. I want to have it as an age group. Select the program and execute it. What is the problem? Sorry.
Age group equal to.
Is equal to. Select it, and this is how we are going to get it. Now, I want to have total value. To have the total value, now I'm writing, here I'm writing the all. Where I'm using this all keyword, I'm using this all keyword in the row dimension. Now you'll get the all in the row dimension here. If you want to have an all in the column dimension, you should write the same thing here. Okay. But if I execute this program, now can you see we are getting too many internal lines? Can you see in the output window? If you do not want to have these lines, you know what you will do? We will write an option called no steps. If I specify the no steps, no separating lines, if I execute the program, you'll get that output window even more precise, even more better. Now, can you see how we are getting? Previously, we used to get so many lines, but now can you see? We are not getting any internal lines. This is how we are going to have. To have that one, we are going to use no steps. And when I did the proc label, proc tablet, here we are going to get the box option. In the box, I want to have a label. If you want to have a label in the box, now we should write, in the table statement, after writing everything, now we should write forward slash, then box is equal to. Now I want to have a name, student demographic report. This is the label I want to have. If the box is equal to label, what will happen now? Now we are going to have a label in the box. Understand this one? This is how we are going to have. Now, I'm writing the proc tablet. Data is equal to data set name. Then I'm writing class statement. In the class statement, I'm writing the sex. If you write anywhere the variable, that variable must be present in the table statement. I'm writing the table statement. Now you know that how we are going to get the data if I write the table statement like this one. I will get the table. You'll get the table categorically. This is how we are going to get. I want to have both count and percentage. If you want to have a count and percent in the table statement, I'm writing a table sex into, now within the parenthesis, I'm writing n and PCTN. Okay, now if I execute the program, we are going to get the both count and the percentage. Can you see? We are getting the n value and we are getting the percentage value. But I do not want to have a label n here. And I do not want to have a label percentage. I do not want to have that statistical keyword. Now, if I do not want to have that one, then what we should do? Now, I'm writing n is equal to empty quotations. PCTN is equal to empty quotations. Okay. Now, see, if I execute the program, it is not going to display n and percentage. Can you see there are no n and no percentage? So you'll get this. We used to get like this one, statistical keywords, but now we are not getting that one. And by the way, I want to have a 47.37% here. I want to have 52.63. I want to have a percentage symbol. Can somebody tell me what we should do if you want to have a percentage symbol here? Anybody?
Format percent.
So you want to manage the percentage format? Where do you want to manage the percentage format, by the way? Where we need to write?
In table after NPCT.
For which statistics that we want to apply the percentage format?
PCTN.
So what do you want to manage? PCTN into?
Percentage.
Is equal to percent. How much? What is the format you want to apply? By the way, I want to have format 47.37%. %47.37%.
Six dots.
6.3.
By the way, if you want to have a 47% minimum, you should write 5 dot. And we discussed that. Then extra, how much I want to have width now? If you want to have 47%, you should write minimum 5 dot. Now I want to have 47.37%, then what is that I should apply? You should write
8.
1, 2, 3, already 5 undi. Already 5 undi. You should 8.2. You should 8.2. And remember, we use a percent in format. Say, for example, in the raw data, I have a 34%. What is the in format I should apply? Percent 3 dot. Okay. If I apply the percent, how the SAS is going to read this value now? How SAS will store that 34%?
0.34.
It will store 0.34. Okay. If you have a 0.34, if you apply again percent 5 dot, you know how that will be displayed? It will be displayed as an again 34%. Okay. So that means when writing in format, if you have a 34%, when you write in format, how SAS is going to store the value? It will divide that value 34 divided by 100. Now it will store as a 0.34. Okay. When we have a 0.34, when you apply the percent 5 dot format, now how it is going to display again?
34.
That means
34.
what it is doing? That means what it is doing? That means here it is dividing by 100, and here it is multiplying with
Into 100. 100.
Now, in the data, I have 47.37. Okay. Now, if we have a 47.37, tell me if I write a percent 8 dot, then how it is going to display?
47.37%.
No. It will multiply
0.
47.37. No. It will display. It will multiply 47.37 into 100. If it multiplies like one, then what is the value you get now? You will get 47.37%. Understand? If you have a data already in the data set, what does it mean? The data is already present in the PDV. We are not using informat here. What we are using? We are using format. I'm telling you, if you have a data value like this one, if you apply the percent 5 dot, it is multiplying 0.34 into 100. Now, in the same way, if you have already 47.37, if you apply the percent 8.2, it will multiply with again 100. Then what is the percentage you will get now? You will get 47.37%. Is that true percentage?
No.
No, sir.
That means already I have a percentage here. I want to have only percentage symbol. That's it. I do not want to multiply with 100. But if you apply the percent format, it will multiply with 100. Did you get my point?
Yes, sir, but this is already there in the PDV now, sir. 47.
In the PDV. Now I will tell you one more thing. Again, see, I am writing a data set name. So for example, input hall ticket number, and then I am writing the marks. Okay. Then I'm writing the data lines. I have 101, 45%. Now I have 102, 78%. I have 103, 89%. Tell me, if you want to read that marks as a numerical data, what is the informative you should write? What is the informative you should write? Informat percent 3 dot.
Percent 3 dot.
When I write the percent 3 dot, how 45% will be saved in SAS?
0.45.
0.45. And 78% will be saved as a 0.78. And 89% will be saved as a 0.89. Now see, if I select the program, execute it, this is how we are going to have a DS1. Can you see how it is saving now? 45% at 0.45. మళ్ళీ ఇప్పుడు నాకు పర్సంటేజ్ లా డిస్ప్లే కావాలనుకో నేను ఏం చేయాలి ఇప్పుడు? If you want display again as a percentage, format, marks,
Mark.
Minimum you should write 5 dot. మరి ఇప్పుడు 5 డాట్ పర్సెంట్ రాసి అనుకోండి, మళ్ళీ 0.5545 ఎలా డిస్ప్లే అవుతుంది? యాక్చువల్ గా మనకి రా డేటాలో 45% ఉంది. ఇప్పుడైతే ఇన్ఫర్మేట్ యూజ్ చేస్తాను 0.45 అయింది. మళ్ళీ ఇప్పుడు పర్సెంటేజ్ యూజ్ చేస్తే ఎలా డిస్ప్లే అవుతుందండి? 45 డిస్ప్లే అవుతుంది. Understand this one. Now see, if I execute the program, I am going to have it as again with the percent. That means again it will multiply by 100. Now we'll get the percentage like this. కానీ ఇక్కడ ప్రాక్ టాబ్లెట్ కి వచ్చేటప్పుడు నా దగ్గర డేటా ఆల్రెడీ ఎలా ఉందండి? In the data set we have 47.37 or something. మరి ఇప్పుడు దీనికి పర్సెంట్ ఫార్మాట్ వాడాను అనుకోండి, ఏమవుతుంది? It will multiply by 100.
Multiply with 100.
But I do not want to multiply, just I want to have percentage symbol. Understand now?
Yes, sir.
Now, how to do this one? Since we cannot use the percent format, I am going to create my own format. Understand this concept? I am going to delete this data set. We do not require anymore. Now,
Yes, sir.
so since I want to apply the percent, now I'm going to create my own user-defined format. How to create user-defined format? Proc
Format.
In this scenario, you should not write the value. You should use a picture format. Okay. I want to create a percentage called PCT. I'm writing, you can write any name, I'm writing a PCT. Generally, when writing a value or in value, what you will do? You will write a start value, hyphen, end value. When you have a range of value. Here, for percentage, what we are going to have is start or end. We are not going to have. We should write a low hyphen, high is equal to. We discussed already this one. Is equal to. You know how I want to display? Each 9 represents one digit. I want to have 99.99%. This is how I want to display. Each 9 display represents one digit. Now I'm writing the run. Now tell me, what is the format I'm creating here? What is the format I created? PCT. Now here I'm using FP is equal to PCT dot. Understand? Now, if I select the program, execute the program, so this is how it is going to get displayed. Can you see now? This is how we create a user-defined format by using a picture statement, and then how it is we are going to use it. Clear, everybody? This
Yes.
is clear, everyone?
Yes, sir.
This is about more or less a proc tablet. Okay. Now, if you are going with a 2 to 3 years experience as a data analyst, proc means proc frequency, proc summary, proc tablet are enough. Okay. But if you want to go with a little bit of extra experience, or if you are more interested in data analysis, I would strongly recommend you, please keep this procedure also. The processor is proc. Proc, the next processor we are going to discuss is proc univariate. But the processor we are discussing now, proc univariate. What is this proc univariate? What is the specialty of this proc univariate? If you want to have a descriptive chances, what is the processor we use?
Proc
Because
means.
descriptive means or proc summary.
Proc summary.
Proc means and proc summary both will do the same thing. Okay. But
So
we
the
have one
four procedures you said, proc means summary, tabulate, and
frequency.
frequency. Thank you.
But we have a very powerful processor called proc univariate. So many people, they don't understand the true value of proc univariate. That's why proc univariate, even though it is a very powerful, not so popular. Because proc univariate is more powerful, better than proc means procedure. Okay, what the proc means can do, proc means can generate only descriptive statistics, but proc univariate is more than that one. So if you keep proc univariate in your resume, definitely you'll get one or two questions from the proc univariate, and you should be able to express, you should be able to discuss and explain the differences between the proc univariate and the proc means, because that is the first question that you'll get. What is the difference between proc univariate and the proc means? Okay, now we'll see that one. Now I'm going to write proc means on the left side. I'm going to write proc univariate on the right side. Proc univariate, proc means, by using a proc means, you can generate, say for example, you can generate P10, 10th percentile, or maybe you can generate P20, or you can generate P30, or maybe you can generate P25 like that one, or you can generate P90, 90th percentile, you can generate P95th percentile, like that one. What proc univariate can do, proc univariate can also do the same, but proc univariate, even it can do customized percentiles. Say for example, I want to have P97.2 percentile, or maybe I want to have P87.91 percentile. So that means by using proc univariate, what we can do, we can generate a customized percentiles. So along with the rounded percentiles, it can also generate, custom percentiles. That is one of the major advantages with proc univariate. And the second one is, by using proc means, what we can do, we can generate one minimum value, we can generate only one maximum value. And then ఇచ్చిన data set low, it can present only the one lowest value and one highest value. Because if you use a min function on any variable, it is going to give the lowest value. If I use a max function, it will get one highest value. But what a proc univariate can do, it can generate 5 lowest values and it can generate 5 highest values. In extreme observations, it is going to present those extreme observations by using, proc univariate. That is the second important advantage with proc univariate. Okay. And what we can generate with the proc means, we can generate the descriptive statistics. We can generate the descriptive statistics. But what a proc univariate can do, along with the descriptive statistics, it can support the normality tests. So that means by using a proc univariate, we can check the normality of the data. In the real time, normality of the data is very, very important. If you want to expect any result, if the data is normal, then you can anticipate, you can predict the result. But if the data is not normal, if the data is not fit for analysis, then you cannot do any inferential statistics on data. If you want to do any analysis in future, first your data should be the normal. Your data should be fit. If you want to check the fitness of your data, normality is one of the major measurement we use to check the normality. By using proc univariate, what we can do? We can do the normality test. Understand? And by using proc means, we cannot generate any graphs. By using proc univariate, we can generate high resolution graphs. Generate high resolution graphs. And by using proc means procedure, we cannot propose any statistical models. You can generate any statistical models, but by using proc univariate, you can propose statistical models. We can propose the statistical models or statistical concepts. So these are the differences between proc means and proc univariate. Very, very important interview question. If we have a proc univariate in your resume, this is the first question that you are going to get. Differences between proc means and proc univariate. So proc means can generate only rounded percentiles, but proc univariate can generate the custom percentiles. And proc means can give only one minimum value and one lowest value and one highest value. But proc univariate can give 5 lowest values and 5 highest values of any variable. And by using proc means you can generate only descriptive stats, but by using proc univariate, you can do the normality test. And by using proc means we cannot generate graphs, we cannot propose any statistical models, but by using proc univariate, you can generate high resolution graphs and we can propose statistical models. Okay. Now,
So
to explain
normal
the,
testing.
yeah, I will explain.
Okay.
Okay. By using to explain the proc univariate, what I'm going to do in today's class, I'm going to take SAS help.shoes. So by using the shoes, I'm creating shoes data set in the work library. So SAS help.shoes. So now we are going to have shoes data set in the work library. I will show you the shoes data set. It is about the shoe sales, the region where the sales information that we have, the product, whether it's casual shoes or boots, like women's casual, whatever it might be. Then we have a subsidiary. Then we have how many states that we have in the location. We have a sales information, inventory, and returns. And this is the data set. We have 7 variables and we have these many observations. We have around 395 observations. I'm using this data set to generate proc univariate. Now I am writing the basic procedure called proc univariate. Semicolon run. But if I execute this program, I am going to have a univariate processor will get run for all the numerical variables of the most recently created data set of work library. But you know the story. Now what I want to do, I want to generate this for shoes data set. I'm writing data shoes. And then I do not want to have analysis for all the numerical variables. I want to have analysis for only sales variable. Then I'm going to write in a var statement. Where I'm writing the sales variable, semicolon. Now select the program and execute the program. So this is how we are going to get the analysis. When you use the proc univariate procedure, by default, in the output window, you will get 5 tables. Remember, you will get 5 tables. The first table that we are going to have in movements. See, can you see what information that we have in the movements table? We have n value, number of observations, mean value, standard deviation, skewness. I will tell you what you mean by skewness. We have UCSS uncorrected sums of squares. We have a coefficient variation. We have a sum weight, some observations. We have a variance, kurtosis, corrected sums of squares, and we have a standard error mean. This is called movements information. Then we have a basic statistical measures. In that, again, we have descriptive statistics like mean, median, mode, standard deviation, variance, range, and interquartile range. And then we have third important one. This is a test for location. We have a student t-test, sign test, signed rank test. And then what we have here, we have the p-value. P-value is very important, whether that value is rejected null hypothesis or the data is normal. And then we have a fourth table, which is a quantiles. 100th quantile, P99, P95, P90, Q3, 75th quartile, 350 is nothing but a median, and 25th quartile, 10, 5, 1, and 0 quartile. Then we have final extreme observations. You know what you mean by extreme observations? It is going to present, as I said, 5 lowest values and 5 highest value. What is the lowest value? Observation number. So out of 395 observations, the lowest sales value is 325, which is present in the 197th observation. Second lowest value, third lowest, fourth lowest, and fifth lowest value. Then the highest value, second highest value, third highest value, fourth highest value, and the fifth highest value, and its observation number. So these are the 5 tables you'll get. Can you see what are the tables you're getting one more time? The first table is movements. The second one is basic statistical measures. Third one is the test for location. The fourth one is the quantiles. And the fifth one is the extreme observations. So you will get 5 tables by default. Okay. Now I want to have a univariate result for sales, but I want to have by region. If you want to have by region, what is the statement you should write?
By statement.
But we have a more sophisticated than the by statement. What is the statement?
Class.
Class.
Because if you use the class statement, you don't need to sort the data and you will get all that information in one table. Now see what is going to happen now. Now we are going to have information for Western Europe. Then we are going to have information for like United States. We are going to have information for each region. We have in South America. So that means for each region, we are getting five tables. Region Pacific, how many regions that we have for each region, we are going to get all the 5 set of tables. Understand this one? So I do not want to have by region, but I want to have only for sales overall information. So how we should write it now? I am writing proc univariate. Univariate data is equal to shoes data set. Then where sales, I want to have only for sales, I'm writing the run. By the way, how many tables I'm getting if I execute this program?
5 tables.
I'm getting 5 tables. But now I do not want to have all the 5 tables. I want to have only quantiles. 1 table. If you want to have only 1 table, now we are going to use a concept called ODS, output delivery system. We should write the before the proc univariate procedure. Now we should write a statement called ODS select. Which table you want to have? You know, I want to have only quantiles table. Maybe I want to have this one. If you want to have a quantiles, now we should ODS select. You should write quantiles. Semicolon, and then you should the proc univariate procedure. Then finally, you should one more time, ODS select close. Now select the program and execute it. Now see what is going to happen. I am going to get now only 1 table, which is a quantiles. Understand this one? Now, remember what are the 5 tables you will get if I execute the program? What are the 5 tables you will get?
Moments, extreme,
Moments, basic,
and
basic
quantiles,
statistics.
Basic statistics. Then we are going to have a quantiles, extreme observations, test for locations. Now see, I am writing proc univariate is equal to shoes data set. I want to have analysis for sales variable. Now write the run statement. Now this available. Now I want to have only test for location. If you want to have a test for location, then what I should do? Can you tell me?
ODS
Yes.
select.
Test for location, semicolon. Then what we should do?
Yes.
Yes, select close. But do you think, can we have a table name like this one in SAS? Can we have a data set or a table name like this one with spaces? No, that means this is not an actual table name. This is a table label because we cannot have a spaces, right? In SAS, if you want to have a table name, that means this is an actual table name. Then what is the actual table name for test for locations? If you want to know any table name which is getting printed in the output window, now we use a concept called, say for example, first of all, I'm writing proc univariate. Proc univariate data is equal to, I want to have shoes data set, I'm writing a data shoes. I want to have analysis for sales variable, where sales. Now write that. So before the univariate, we use a procedure called ODS trace on. This is called a ODS option. And at the end of the program, we should write ODS trace off. If I write these 2 statements, what will happen? Now in the log window, please tell me, if I use the proc univariate procedure, how many tables I'll get in the output window? For all the 5 tables. Now in the log window, it will write the table name, the table label, the path, and the template of each table. So ODS JSON is going to print that table information in the log window. Of course, you will get the information output when that is fine. I'll go to the log window. Now, this is what you can see in the log window. Can you see for each table what I'm getting? Name of the table, label of the table, template of the table, path of the table. So that means now tell me, what is the table name for test for location? The table name is test for location without space. Copy this location, copy the table name. Then what should I write now? I should write ODS, select, now the table name, semicolon. Then what we should write now? ODS, select, close. If I execute this program now, it is going to print only test for location. Can you see this one? Clear, everybody? Now, I want to print a text for location, and I want to print even the movements also. If you want to print it two tables, now what I should do, you should write a proc univariate data is equal to shoes data set where sales semicolon run. If you want to print two tables, now we should write ODS, select. Now I'm going to write test for location. Then I want to have movements also. Now we should write both the tables. Now we should write ODS, select, close. If you select the program and execute the program, this is how we are going to get. Now, can you see how many tables I'm getting now? I'm getting movements and test for location. Now, in the same way, I do not want to print these two tables. I want to have the remaining three tables. So if you want to have the remaining tables, not these two tables, you know what we should write? Now we should write ODS exclude. If I specify ODS exclude, you know what will happen now? It will omit these two tables. So that means we are going to get the remaining three tables. Can you see? Now I'm getting the I'm getting basic statistical measures, quantiles, and extreme observations. Understand this one? So far, where we are getting this information? Yes.
ODS select close, right? There also we should write
No,
select
you don't
all.
write it. No,
Okay, sir.
only when you're starting, only should write it.
Yes.
Now, so far, where you are getting all this information? We are getting this information in the output window. But now I want to save the information to a data set. Now I want to save, say for example, extreme observations information. Now I'm writing proc univariate data is equal to shoes data set where sales data set, then run. If you want to save any table information, now before the proc univariate procedure, we should have ODS, then we should write a output. Which table information I want to have? Extreme observations. Extreme observation table name is equal to, okay, now we'll see that one, how we have extreme observations table name. Extreme OBS only. Now I'm taking the table name, go to the program. Extreme OBS is equal to extreme OBS is equal to what I want to have, say for example, a table called outline. Now keep a semicolon. At the end of the program, we should add ODS output close. Now if I execute the program, now the information, of course, you will get in the output window, but now say what is going to happen now that information has been saved into a data set. Variable name, the lowest value, the observation number, highest value, and the observation number. In this way, if you want to save any table information to a data set, we use ODS output. Then we are going to write table name is equal to the data set name.
Sir,
Yes.
the table names are vary from one data set to other, sir, or standard.
Which one? This one or this one?
Test for location or extreme movements, those names, sir.
I told you, no, we have five tables. When we execute the proc unit, how many tables will you get? Five tables,
Five
right?
tables.
So the first table name is movements. The second table name is basic statistical measures. Third one is the test for location. Fourth one is quantiles. Fifth one is
Extreme
extreme
observation.
observation. Those are the table names that we have.
Yes, sir.
We cannot get all the into one data set. We can get into only one. Now, how to check the normality of a data set or a normality of data? Okay, now we'll see. We can check the normality of the data in three different ways by using the proc univariate procedure. The first one is by plotting the histogram, by using the graph. And the second one is by calculating the skewness. And third one is by doing the normality test. By using these three measurements, we can check the normality of the data. So by using histogram, by using the skewness, third one is by doing the normality test. First, we'll plot the histogram. So now I'm writing this one. Proc univariate data is equal to choose data set. I want to have information for sales variable. I'm writing var sales. Then I'm writing a statement called histogram. And I want to have normality. Normal. Now keep a semicolon. Now write the run statement. Now, if I select the program, execute the program, we are going to have a measurement, so all the five graphs, and then followed by, we are going to have, the histogram. Do you have anybody statistics graduate in our class? MS or BSc statistics graduate? Anybody? No one? How to interpret the histogram? Anybody knows?
No.
If you're using a histogram is going to be a bell structure. This histogram bell structure the curve should be present in the center of the graph. If we have this in the center of the graph, now we can say the data is normal. But can you see how we have that bell structure? We have onto the extreme left side. Sailaja, is it correct?
Yes, sir.
It should be in the
If it is
center.
on the positive side, then it is positively skewed. If it is on the negative, it is negatively skewed.
So the graph should be, the bell structure should be in the center. So we do not have in the center. That means that this data is not normal. So it failed the histogram structures. Now, the second one, what I want to do, I want to check the skewness. Now, how to check the skewness? Now I'm writing proc univariate. Data is equal to choose data set. I want to have analysis for sales variable. I'm writing the run. Now, if I execute the program, we have a first table called movements. Remember? We have movements. In the movements table, can you see what the skewness that we have? How much skewness that we have? 3.94. 3.94. If the data is not normal, how the skewness can be? Skewness can be as close as possible to 0. If the skewness is close to 0, we can say the data is normal. But if it's varying from the 0, it is going away from the 0, we can say the data is skewed. That means the data is not normal. So the more the skewness is the less the normal. Understand this, skewness should be as close as possible to 0. Okay, if the skewness is greater than 0, we can say the data is positively skewed. We can say the data is positively skewed. If the skewness is less than 0, we can say the data is negatively skewed. Understand this, sir? So, for example, if the skewness value is, so as I said, if you have a 0, that means a highly 100% data normal. But if the skewness is greater than minus 0.5, example, less than plus 0.5, అంటే స్క్యూనెస్ కనుక మైనస్ 0.5 కి ప్లస్ 0.5 కి మధ్యలో ఉందనుకోండి, we can say the data is approximately skewed. That is approximately skewed. But if the skewness is present between -1 and +1, and then we can say the data is moderately skewed. The data is moderately skewed. If the data is less than -1 or if the data is greater than +1, okay, then you can say the data is highly skewed. So minus 0.5 కి ప్లస్ 0.5 కి మధ్యలో ఉందనుకోండి, approximately skewed అని. If it is present between -1 and +1, we can say moderately skewed. But if it's less than -1 or greater than +1, we can say highly skewed data. Now, the skewness is two types: positive skewed data, negative skewed data. You know, as I said, if we have greater than 0, then what we call it it is a positively skewed data. Now tell me that this data is positive skewed data or negatively skewed data?
Negatively skewed.
Positively skewed.
Positive.
3.9.
Positively skewed.
Positive.
Is it approximately skewed, moderately skewed, or highly skewed?
Highly skewed. sir.
Skewed.
It is
Highly skewed.
greater than +1. It is a highly skewed data. Why you will get a positive skewed data? You know, if you have a few values which is extremely larger than the average value, అంటే average value కన్నా few values కన్నా extremely large గా ఉన్నాయి అనుకోండి, then you'll get a positive skewed data. If you have few values extremely smaller than the average value, then you'll get a negatively skewed data. అంటే average కన్నా కొన్ని వాల్యూస్ కనుక చాలా హైయెస్ట్ వాల్యూస్ ఉన్నాయనుకోండి, లార్జ్ వాల్యూస్ ఉన్నాయనుకోండి, ఏమవుతుందండి? పాజిటివ్లీ స్క్యూడ్ డేటా అవుతుంది అన్నమాట. ఒకసారి మీకు నేను ఎగ్జాంపుల్ చూపిస్తాను చూడండి. ఒకసారి యావరేజ్ వాల్యూ ఎంత ఉందో చూడండి. సేల్స్ యావరేజ్ వాల్యూ ఎంత ఉందండి? 85,000. ఓకేనా? నౌ ఐఎమ్ గోయింగ్ ఓవర్ హియర్. we have few extreme observations. ఒకసారి హైయెస్ట్ వాల్యూ ఎంత ఉందో చూడండి. 12 lakhs 98,717. యావరేజ్ వాల్యూ ఎంత? 85,000. హైయెస్ట్ వాల్యూ ఎంత 12 lakhs. అంటే ఫ్యూ వెరీ ఎక్స్ట్రీమ్ అబ్జర్వేషన్స్ ఉన్నాయి, ఎక్స్ట్రీమ్ హైయెస్ట్ వాల్యూస్ ఉన్నాయి. కాబట్టి మీకు ఏమవుతుందంటే పాజిటివ్ స్క్యూ డేటా వచ్చేస్తుంది. అండర్స్టాండ్ దిస్ వన్. So the second measurement for the normality of the data is skewness. Now tell me, మరి ఇప్పుడు skewness బేస్ చేసుకుని ఈ డేటా నార్మల్ లా కాదా? This data is not normal at all because the skewness that we are getting is 3.9, which is very bad. The data is not normal because the lowest value ఎంత ఉందో చూడండి. What is the lowest value that we have? 325. And what is the highest value that we have?
12 lakhs 98.
12 lakhs
almost
98,000.
almost 13 lakhs. So ఎంత రేంజ్ ఉందో చూడండి. Now I write the same program and proc SAS algebra class. చూడండి, SAS algebra class రాస్తాను. ఇప్పుడు proc univariate అని రాస్తాను. data is equal to SAS help dot class రాస్తానండి. నాకు అనాలిసిస్ ఎవరికి కావాలంటే ఏజ్ కావాలి. ఏజ్ లో వాల్యూస్ ఎలా ఉంటే మీకు ఐడియా ఉందా? లోయెస్ట్ వాల్యూ ఎంత ఉంటుందండి?
11 sir.
11.
హైయెస్ట్ వాల్యూ ఎంత ఉంటుందండి?
16.
మొత్తం టోటల్ 19 వాల్యూస్ కూడా ఎక్కడ ఉంటాయండి? 11 to 16 ఉంటాయి. మీకు యావరేజ్ ఎంత ఉంటుందంటే మేబీ 13.3 నో 2 నో 4 ఎంత ఉంటుందండి, ఇఫ్ ఐఎమ్ నాట్ రాంగ్. అంటే ఇది వెరీ క్లోజ్ డేటా. చూడండి, ఇప్పుడు ప్రోగ్రామ్ ఎగ్జిక్యూట్ చేస్తాను, 5 టేబుల్స్ క్రియేట్ అవుతాయి. ఒకసారి నేను మూమెంట్స్కి వెళ్తాను, స్క్యూనెస్ ఎంత ఉందో చూడండి.
0.06.
0.06 అంటే అప్రాక్సిమేట్లీ అండి వెరీ క్లోజ్ టు జీరో.
Very close.
Little bit positive, but very close to zero. That means very normal. Understand this one? ఎందుకంటే the lowest value we have is 11, the highest value that we have 16, but what is the average value that we have? The average value 13.31 or something. అంటే lowest value 13 కి చాలా దగ్గరగా ఉంటుంది, highest value కూడా 13 కి చాలా దగ్గరగా ఉంటుంది. So we have very normal data. సో జీరోకి ఎంత దగ్గరగా ఉంటే స్క్యూనెస్ డేటా అంత నార్మల్ గా ఉందంటాం అన్నమాట. అండర్స్టాండ్ దిస్ వన్? క్లియర్ ఎవ్రీబడి?
సార్ ఇప్పుడు స్క్యూనెస్ ని ఎలా డిఫైన్ చేస్తారు సార్? అంటే నార్మల్ గా
it's a we can explain it as an it is a it's a degree of property that explains the asymmetry of the data. అంటే డేటా ఎంత ఈవెన్ గా ఉందో చెక్ చేయడానికి యూజ్ చేస్తుంటాం అన్నమాట. It is a measure of degree of asymmetry of distribution of the data. అంటే డేటా ఎలా డిస్ట్రిబ్యూట్ అయిందో చెప్తుంది అనమాట. ఓకే
ఓకే సార్, థ్యాంక్ యూ.
Then we have the third one, normality test. So దానికోసం చూడండి నేను ఏం చేస్తాను, again I'm using a proc univariate procedure. Proc univariate, data is equal to shoes. Data is equal to shoes. I want to have analysis for sales variable. So I'm writing the run statement. Okay, while I'm doing this one, I'm using a keyword called normal. Okay, now see, if I execute the program, I am going to get the normality test. So now this is what I'm going to get it. Test for normality. In the normality test, we are going to measure the p-value. We'll measure the p-value. What the p-value can be? If the p-value is less than 0.05, we can say it rejects a null hypothesis. Okay? p-value కనుక less than 0.05 ఉందనుకోండి, ఏమంటాం దాన్ని? It rejects null hypothesis అంటాం. అదే greater than 0.05 ఉందనుకోండి, we can say the data is normal. The distribution is normal. మరి ఇప్పుడు చెప్పండి, నాకు p వాల్యూ ఎంత ఉందో చూడండి, ఇక్కడ బేస్ చేసుకుని p వాల్యూ చెప్పండి. Less than 0.0001, which is rejects hypothesis.
null hypothesis.
మరి ఇదే ప్రోగ్రామ్ మనం ప్రాక్ SAS కి క్లాస్ రాసినప్పుడు p వాల్యూ ఎంత ఉందో చూడండి. దిస్ ఇస్ నాట్ దట్ వన్ వేర్ వీ హ్యావ్ దట్ check where we have that one SAS dot class one. This one. Now can you check what is the p value on this one? I will let the same procedure for a SAS dot class. Okay. If in the same way procedure for the SAS dot class, now can you see what is the p value that we have?
0.1736.
One second. Which is greater than- What is that one? Is it like less than 0.05 or greater than 0.05?
Greater than.
So that means the data distributed normal.
Normally.
Understand? But again, I'm executing this program. ఒకసారి చెక్ చేసుకొని చూడండి. ఇక్కడ p value చూడండి. We have two different types of p values here. Of course, we have four different types of p values. But most important ఏంటంటే Shaparov-Wilk test, Kolmogorov-Smirnov test and two tests ఉంటాయి. If the sample size is less than 2000, we will take Shaparov-Wilk test as a standard. If the sample size is greater than 2000, we'll use Kolmogorov-Smirnov test. మరి ఇప్పుడు మన శాంపుల్ సైజ్ ఎంత ఉందో ఐడియా ఉందా? 395 observations. Now, which test you should take as a standard? You should go with Shaparov-Wilk test. దీన్ని మనం బేసిస్ గా తీసుకోవాలి. మీ శాంపుల్ సైజ్ కనుక గ్రేటర్ దాన్ 2000 ఉందనుకోండి, యూ షుడ్ గో విత్ Kolmogorov-Smirnov test వెళ్ళాలి. You don't require all this concept. According to that specifications and mock shells, you will run the code and you will submit the report to the client. Then the biostatistician is going to see the result. He is going to write the medical writing. He is going to interpret the result. You are not the person who should interpret the result. Okay, na? Miru clinical science programmer, the statistical programmer, you will run the program and you will generate the report. You will submit that one, but who will take that? Who will take the responsibility to interpret the result? The biostatistician will do that one. The person who has done PhD in the biostatistics, he is going to take care of that medical writing. By seeing the result, he is going to write a hypothesis and he is going to submit it. Understand? Is this there?
క్లినికల్ డొమైన్ లో వాడతామా సార్ ఇది?
Of course we use.
ఓకే సార్.
Okay then. See you continue in tomorrow's class. Okay?
Sure, sir, not share.
Sir, code chat box.
Not.
సార్ ఎస్టర్డే